In this demo, I'll be showing you how ownership works in the Rust programming language. Ownership is Rust's model of memory management and is used to keep your programs running fast and free from memory leaks. Here we have a demo program. There is a struct called book. It consists of a number of pages and a rating for the book. We have two functions. The first just displays the page count by printing out the number of pages by referencing the pages field. The second function displays the rating by accessing the rating field. In our main function, we are creating a single book with 5 pages and a rating of 9. All data in a program is owned by some other part of a program. If we take a look at this book variable, it is owned by the main function because that's where we created the variable. It's the responsibility of the owner, in this case the main function, to clean up the memory. And when it cleans up the memory, this is called a drop. So they're dropping the memory. Memory gets automatically dropped once the end of the block is reached. So this is the block for the main function. So once execution reaches here, this book will automatically be dropped. This is code that you don't have to write. It gets added automatically. This code between the curly braces is also known as a scope. So you can refer to it as a scope or as a block. Now let's call one of these functions. I'm going to call the display page count function. And we'll call that with the book. Now what's happening here is that ownership is being transferred. So as we can see, we created this variable inside the main function, as we can see by the block. Once we call this function, ownership is transferred into this function. So we take this book, we're calling the function by giving the book to the display page count function. That then gets moved here, and this function becomes the new owner of this book. And it has its own scope or its own block. And once this block finishes executing, the book is going to get dropped because the owner is responsible for cleaning up the memory. So the display page count function is going to drop the book. What this means is once this function is executed, the book will no longer be available later on in the program. In our current program, that's not an issue. But if we were to try to use the book again, let's say we wanted to display the rating, this program will no longer work because we transferred ownership of the book into this function. Then the function finished executing and dropped the book. And so the book no longer exists once we get to this line because this function here got rid of it. So let's try to run the program and we'll see what happens. Here we can see we get a compiler error, and the error indicates that we used a moved value. And it gives us a description of what happened. So the value was moved into the display page count function, and then we tried to use it again in the display rating function. So let's try to fix that. In order to fix this, we need to do what is called borrowing. So instead of moving the ownership into these functions, we're going to have these functions just borrow the data. So when a piece of data is borrowed, the function is not allowed to drop it because the owner is still the original owner. In order to borrow data, we use the ampersand symbol. So here the display page count function is now accepting a reference to a book. This is also known as borrowing. So they're just borrowing this book, and then they're going to give it back. We'll do the same thing for our rating function. And now to call the functions, we also supply the ampersand. And now everything should work correctly. So now let's walk through it again. We have a book. It's owned by the main function. We are letting the display page count borrow the book. And so since the main function still owns the book, the display page count function cannot delete it. We then let the display rating function borrow the book here, and then it will display the rating, and it won't get dropped because they're just borrowing it. And so now our program should compile, and we should get the page count and rating displayed. So let's try it and see what happens. And here we go. We have the number of pages and the rating displayed for our book. The reason we need to do all this is for efficiency and memory management. If we had a data structure that was large, like several megabytes, if you were to transfer ownership of that structure to different functions, it would require copying all that data each time you use a function. But if you just let a function borrow it instead, then it performs much quicker because the data stays in one place and the function can simply borrow the data and then give it back. So there's huge performance implications to having borrowing versus transferring of ownership. The book struct that we made is pretty small. It just has 2 pieces of information. So this would be something that would be okay to copy around and move ownership of. This concludes the demo on ownership. I'll see you in the next presentation.